Okay, this is from section 1.3. We're going to do problems 24 through 28. And here it says there are 6 people from West Virginia, 5 people from Maryland, 4 people from Pennsylvania in a classroom. The teacher asked for 3 different students to do a problem on the board. What is the probability that, first of all, in problem 24 it says all 3 people are from West Virginia? Well, the probability the first one's from West Virginia is 6 out of 15 because there's 6 people from West Virginia there's a total of 15 people to choose from. So the probability the first one's from West Virginia is 6 out of 15. Now you multiply that times the probability that the second one's from West Virginia given that the first one was from West Virginia. So the probability that the second one's from West Virginia given that the first one's from West Virginia is 5 out of 14 because we already used up one person from West Virginia, so that knocks the 6 down to 5, and we knocked the number of people to choose from 15 down to 14. And then you multiply it by the probability that the third person is from West Virginia given that the first 2 are from West Virginia. We now have 4 people left from West Virginia, and we have a total of 13 people left. So you multiply these fractions together and you get 4 out of 91. Okay, and that's that problem right there. Now a different problem that's not in your book says, what is the probability that not all 3 people hired are from West Virginia? Well, this is exactly the opposite of all 3 people being from West Virginia. So to get the answer to this one right here, just do 1 minus the previous answer. And 1 minus 4 out of 91 is 87 out of 91, or 1 minus this decimal is this decimal here. Now this problem is in your book. It says none of the 3 people were from West Virginia. That sounds a lot like this problem I added, but it actually is different. None of the 3 people from West Virginia means that not one person can be from West Virginia. So all 3 people here have to be different than West Virginia. Now up here, this extra one here that I did, not all 3 people hired are from West Virginia. That means that 2 or even one of the 2 people, one or even 2 of the 3 people could be from West Virginia. So for example, West Virginia, Maryland would count in here, whereas here West Virginia, Maryland would not count. So to do this one, we have to get the probability that the first one's not from West Virginia, which is 9 out of 15. Because there are 6 people from West Virginia and 15 people total, there are 9 people that are not from West Virginia. Then once that one's chose, you have 8 people left that are not from West Virginia, and that would be out of the 14 people that remain, and then times the 7 that are not from West Virginia out of 13. If you simplify these fractions, you get 12 out of 65, or if you do it on a calculator, you get 0.185. Remember, if you do these on a calculator, remember to put parentheses around the fractions. On 26, it says the first one chosen is from West Virginia and the next 2 are from Maryland. So here's the order we're talking about: West Virginia, Maryland. Well, the probability the first one's from West Virginia is 6 out of 15 because there's 6 from West Virginia and 15 people total, times the probability the next one's from Maryland. Well, you still have 5 people remaining from Maryland because the first one had to be from West Virginia, but you're down to 14 people. And then the probability the next one's from Maryland, well, you used up one of these 5 people from Maryland, so now you're down to 4 people from Maryland, you're down to 13. So it turns out to be the same fraction, luckily enough, and that's 4 out of 91, which is the same fraction decimal we had up above. On 27, it says 2 of the 3 people chosen are from Maryland and 1 is from West Virginia. Now notice the order was not specified here. So if the order is not specified, it could happen the way it's listed above here: West Virginia, Maryland, or it could happen Maryland, West Virginia, Maryland, or it could happen Maryland, West Virginia. That's the 3 ways it could happen. Each of these have the same probability of 4 out of 91. So since it could happen these 3 ways, just multiply your 4 out of 91 by 3 to get 12 out of 91. Or as a decimal, multiply the 0.04395 times 3, and you get the decimal equivalent. And 28 is similar. It says, what's the probability that all 3 people are from a different state? Well, first figure out one way that they could be from a different state. Like, for example, the first person from West Virginia, the second person from Maryland, and the third from Pennsylvania. Well, probably the first one from West Virginia is 6 out of 15. Next one from Maryland is 5 people from Maryland, and we haven't used any up yet because the first person was from West Virginia, so that'd be 5 out of 14 because we did use up one person. That knocked that down. And then how many people from Pennsylvania? Well, there's 4 people from Pennsylvania, and that's out of 13. Multiply these fractions together, you get 491. Now, it didn't say that the first had to be West Virginia, the second was Maryland, third Pennsylvania. It just said they had to be from each one had to be from a different state. So list all the ways they could be from a different state. So here's one, WMP. Then here's another one, WPM, meaning first is from West Virginia, second is from Pennsylvania, third from Maryland. So that's both with the starting letter of W. Now let's start with a starting letter of M. So we got MPW and MWP. and then PMW and PWM. So there's 6 ways that could occur. So just multiply this 4/91 by 6 and you get 24 out of 91, and you can get that as a decimal. So that's all these type of problems. You definitely see problems like this on tests, and they could be about marbles or people from different places and so on. And also in the next section, section 1.4, they show another way to do these with combinations and permutations, but some people like that way and some people just choose to stay with this way. So I'll stop this video there.